Valence shell electron pair repulsion theory. To explain the bond angles in the molecules with 3 or more than 3 atoms attached to a central atom through covalent bonds, a theory called the valence shell electron pair repulsion theory was proposed by Sidgwick and Powell in 1940 and further improved by Gillespie and Nylohm in 1957. Features of this theory are: according to the theory, the shape of molecule depends on the number of bonded or non-bonded electron pairs around the central atom and repulsions and attractions of lone pair and bond pair present in valence shell around the central atom. That is, the repulsion between lone pair, lone pair, bond pair and bond pair. This theory can be used to predict the structure of a molecule, including approximate bond angles around the central atom of a molecule based on Lewis structure. This theory can also be used to predict the arrangement of electron pairs around the nucleus of central atom. Lone pair is unshared electron pair or non-bonding electron pair which do not involve in bond formation. They are attracted only to nucleus. Lone pair always tries to repel the bond pair of electrons. As a result, bond angle decreases from its original value. Bond pair of electrons directly involves in the formation of bond and are attracted by two nuclei. Formation of beryllium chloride molecule. If the central atom in certain molecule has two bond pairs and no lone pair of electrons, then the geometry of the molecule is linear and the bond angle between the bond pairs is 180 degrees. This can be explained by considering the beryllium chloride molecule. Beryllium. Atomic number of beryllium is 4. Electronic configuration of beryllium is 1s2, 2s2. Number of valence electrons in the outermost shell of beryllium is 2. Each beryllium can pair up with 2 more atoms to achieve octet configuration or stability. Chlorine. Atomic number of chlorine is 17. Electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. Number of valence electrons in the outermost shell of chlorine is 1. Each chlorine can pair up with 1 atom. One beryllium atom can pair up with 2 chlorine atoms and form beryllium chloride molecule. In beryllium chloride molecule, around the nucleus of central atom, that is beryllium, there are 2 bond pairs of electrons with no lone pair of electrons. The bond angle of beryllium chloride is 180 degrees. The shape of beryllium chloride molecule is linear. Formation of boron trifluoride molecule. If the central atom in certain molecule has 3 bond pairs and no lone pair of electrons, then the geometry of the molecule is trigonal planar and the bond angle between the bond pairs is 120 degrees. This can be explained by considering the boron trifluoride molecule. Boron. Atomic number of boron is 5. Electronic configuration of boron is 1s2, 2s2, 2px1. Number of valence electrons in the outermost shell of boron is 3. Each boron can pair up with 3 more atoms to achieve octet configuration or stability. Fluorine. Atomic number of fluorine is 9. Electronic configuration of fluorine is 1s2, 2s2, 2px2, 2py2, 2pz1. Number of valence electrons in the outermost shell of fluorine is 1. One boron atom can pair up with 3 fluorine atoms and form boron trifluoride molecule. In boron trifluoride molecule, around the nucleus of central atom, that is boron, there are 3 bond pair of electrons with no lone pair of electrons. Bond angle in boron trifluoride is 120 degrees. The shape of boron trifluoride is trigonal planar. Formation of methane molecule. If the central atom in certain molecule has 4 bond pairs of electrons, then the geometry of molecule is tetrahedron and expected bond angle between the bond pairs is 109 degrees 28 minutes. This can be explained by considering the molecule methane. Carbon. Atomic number of carbon is 6. Electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1. Number of valence electrons in the outermost shell of carbon is 4. Each carbon can pair up with 4 more atoms to achieve octet configuration or stability. Hydrogen. Atomic number of hydrogen is 1. Electronic configuration of hydrogen is 1s1. Number of valence electrons in the outermost shell of hydrogen is 1. So that each hydrogen can pair up with 1 atom. 1 carbon atom can pair up with 4 hydrogen atoms and form methane molecule. In methane molecule, around the nucleus of the central atom, that is carbon, there are 4 bond pairs of electrons, and the bond angle between the carbon and hydrogen is 109 degrees 28 minutes. Structure of methane is tetrahedron. Formation of ammonia molecule. If the central atom in certain molecule has 3 bond pairs and 1 lone pair of electron, the geometry of the molecule is trigonal pyramidal and the bond angle between the bond pairs is less than 109.5 degrees. This can be explained by considering the molecule ammonia. Nitrogen. Atomic number of nitrogen is 7. Electronic configuration of nitrogen is 1s2, 2s2, 2px1, 2py1, 2pz1. Number of valence electrons in the outermost shell of nitrogen is 3. Each nitrogen can pair up with 3 more atoms to achieve octet configuration or stability. Hydrogen. Atomic number of hydrogen is 1. Electronic configuration of hydrogen is 1s1. Number of valence electrons in the outermost shell of hydrogen is 1. So, each hydrogen can pair up with 1 atom. 1 nitrogen atom can pair up with 3 hydrogen atoms and form ammonia. In ammonia molecule, around the nucleus of central atom, that is nitrogen, there are 3 bond pairs along with lone pair of electrons. The bond angle in ammonia changes from 109 degrees 28 minutes to 107 degrees 48 minutes. Structure of ammonia is trigonal pyramidal. Formation of water molecule. If the central atom in certain molecule has 2 bond pairs and 2 lone pair of electrons, the geometry of the molecule is tetrahedron. This can be explained by considering the water molecule. Oxygen. Atomic number of oxygen is 8. Electronic configuration of oxygen is 1s2, 2s2, 2px2, 2py1, 2pz1. Number of valence electrons in outermost shell of oxygen is 2. Each oxygen can pair up with 2 more atoms to achieve octet configuration or stability. Hydrogen. Atomic number of hydrogen is 1. Electronic configuration of hydrogen is 1s1. Number of valence electrons in the outermost shell of hydrogen is 1. So each hydrogen can pair up with 1 atom. 1 oxygen atom can pair up with 2 hydrogen atoms and form water molecule. In water molecule, the central oxygen atom has 2 lone pairs of electrons and 2 bond pairs of electrons. So, the bond angle of water molecule is 104 degrees 5 minutes. The structure of water molecule is V shape or bent shape or angular.